All right, my name is Mr. Smith. Welcome to the Academy for Allied Health and Biomedical Sciences. We are beginning with chemistry. And like everything else, the best way to start off our presentations is to start right in Chapter 1, where we're going to have an introduction to chemistry and what chemistry is all about. I want you to pay particular attention to what we present as we do so, and it will give you an excellent foundation for what we're going to conduct in class. This is going to be done as a video, section by section. An entire chapter takes up way too much, so we're going to break this down into sections. We're starting with section 1, which will look at a story of two substances. The following videos will cover section 2, chemistry and matter, finally next, scientific methods, and finally, scientific research. So we're going to start with looking at two substances, which means, of course, we'll get to define the term substance. We'll look at the formation and importance of ozone, and we'll describe the development of chlorofluorocarbons. Some review. Vocabulary: matter is anything that has mass and takes up space. Our new vocabulary is, of course, chemistry and substance. The idea for this section is to understand that chemistry is the study of everything around us, which is why my first question to you on Edmodo dealt with formaldehyde and how formaldehyde will affect ozone. So, why do we want to study chemistry? Well, you guys are going into allied health. So if you want to have an understanding for people, their health, how health becomes important, believe it or not, you've got to understand the chemistry of them. Now, to help you do that, this course is going to give you a foundation in chemistry so that you can then apply that foundation to what you need to know as we move forward. First, you need a basis of knowledge. That's what I'm here to provide. And that's what you're going to get when you come into class. So, chemistry talks about all the stuff in the universe made from building blocks formed in stars. That is very important. What you really want to understand is when you come in and take a look at a periodic table, the periodic table I've provided you, the periodic table that you're going to see on the wall in my room, periodic table in chapter 6 of your book, the first 92 elements of that table are what we call naturally occurring. The last group, up to 114, from 93 to 114, are not natural. They're actually man-made. These building blocks make up everything called matter. You put them together and you will get everything in the universe. Everything in the universe from these 92 elements. Chemistry is the study of this matter and the changes that it undergoes. From creation of stars to creation of planets, to the Krebs cycle, to the water cycle, to the CO2 cycle, to anything. We're going to concentrate, and your book concentrates, on taking a look at the ozone layer. The ozone layer is an area of about 40 kilometers in the stratosphere that actually protects us from ultraviolet light. Ultraviolet light is light you actually can't see. It's above the violet area in the spectrum. It is electromagnetic radiation. It comes from the sun, and it can UVA, UVB, look up any of that in Google, and you'll find that those things will damage living organisms. It causes skin cancer. One of the most successful things we've done is create suntan creams and sun lotions that will block so much of the UVA and UVB that actually there's a lot of people who could go out, you slather that stuff on your skin, and you'll never get a tan. You'll never change color. A tan actually is damage. It's UVB affecting your skin, and your skin responds by releasing something called melanin, which makes your skin dark. That means you being damaged by ultraviolet light. The Earth's atmosphere contains this ozone. And because it's there, it actually reflects a lot of the UVA and UVB rays, really a lot. And because of that, we're protected. We can go outside without actually using skin protection. Now, over time, no protection means you're going to burn, you're going to get skin cancer, etc. But this ozone layer, without this ozone layer, you would literally fry. You would always get a sunburn. You get a sunburn just from walking down the block. Here is a look at what you actually might call a model. I'll go into what a definition of model is in other sections of this chapter. But here's a model of the atmosphere. Notice at the top, it's about 500 kilometers altogether till you hit what's called the exosphere, which is really the very outer edge of the atmosphere. That's where we keep our satellites. All our communication satellites, those of you who use DirecTV or Dish Network, those satellites, the satellites that allow you to make a phone call, those exist up here in the exosphere. The space shuttle and other rockets that have men in them, including the International Space Station, actually exist and are found in the thermosphere. They use the thermosphere. They get above the mesosphere, but they're not quite all the way out to space. Part of the reason for that is if you get above 500 kilometers, the satellites, they're small. They're enough that the gravitational pull of the Earth will pull on them and keep them in an orbit around the planet. But if you go too much farther than 500 kilometers, the actual pull of the gravity by the Earth on our object, like the International Space Station, it could potentially actually leave orbit if we kept it above 500 kilometers. So we keep it among that. We'll talk about why that is actually when we get into physics. You then have, of course, the mesosphere, and here you can see the ozone layer in the stratosphere from 10 to 50 kilometers. Notice jets come up there. And when you guys were talking about formaldehyde, you talked about formaldehyde in exhaust. Think about it. Jet fuel is similar to gasoline. And some people were talking about formaldehyde in car exhaust. Think, is formaldehyde in jet exhaust? Okay, so what is ozone? Ozone is a substance. Why is it a substance? It's a substance because you can make a formula out of it, O3. Oxygen. Oxygen is also a substance. Why is it a substance? Because you can make a formula out of it, O2. A substance, therefore, is also known as a chemical, and it has a definite composition. So substances have definite composition, which means we can write a formula about them. What formula can we write? Well, how about writing H2O? That's the most common, right? What is that? Dihydrogen monoxide, also known as water. Taking a look at ozone and the ozone layer, we discovered how ozone is formed. The ultraviolet radiation that we want to protect our skin and protect our bodies from, with oxygen in the atmosphere, what it actually does is it helps oxygen, it radiates on oxygen, and that ultraviolet radiation also is energy. And that energy can help with letting the O2 molecules, letting one of them split apart, as you see here in this model, and form ozone. So here's one model of how ozone is formed. There are different and other models, and again, I'll explain models shortly, but notice I use models and we write models almost from the beginning, and you're going to learn about models when we get into class. In the mid-80s, a few scientists discovered that in the ozone layer over Antarctica, you literally had a hole where there was no ozone whatsoever. Now, you say, hey, no ozone over the Antarctica, who cares? Well, we know from a lot of things that we've been looking at that there's penguins that live there. The other thing, though, that happens is when you imagine electromagnetic radiation, you need to realize that electromagnetic radiation does not come linear. Electromagnetic radiation radiates, which means that it's going to go everywhere. So that little hole over the Antarctic means that unfiltered ultraviolet rays, and cosmic rays for that matter, come right into the planet and go everywhere. Which means right here in Woodbridge, we are exposed to ultraviolet radiation on a larger scale because this hole allows more ultraviolet radiation to come in. Okay, that's a concept that you need to think about. That's a problem. So what's causing this hole? Well, remember this section is a tale of two substances, the one substance being ozone. Here's the other substance, a chlorofluorocarbon. Notice it's got CFC, okay? It actually should be ClFC, Cl for chlorine, because that's the symbol for chlorine you'll find on a periodic table. F, fluorine, C, carbon. That, though, is a little bit of a formula. Therefore, chlorofluorocarbons are a substance. They're definite. They have a definite composition. Chlorine, fluorine, carbon. They were used in coolants for your air conditioner. They were used for the air conditioner in a car. They were used for helping make refrigerators. We don't use them anymore, but they were. They also were found to be really great with aerosol cans in helping to get out well, real simple one for the girls would be any of you who use hairspray. I don't even know if hairspray is used that much these days, but it would get out hairspray. You certainly use it when you try to use Lysol or one of those aerosol cans to clear the air. Spray paint, they all use that kind of thing. CFCs were tested and used extensively. There's a whole chapter in Napoleon's Buttons that you read over the summer that actually talks about CFCs and their development. We thought they were the greatest things. Why? Because they didn't react with human beings. They didn't react actually with any kind of living organisms. We put cockroaches in there. We put rats in there. We exposed them to all this CFC, let them breathe it in, and what happened? Nothing happened. So what did we think? Hey, here's a safe, non-toxic way that we can use gas, and guess what? It helps keep our area cool. This is great stuff. Well, here's what starts to happen. People start to keep track of this CFCs, and of course, we're doing more and more study. People are doing more and more research. Notice in 77, we had about 140 PPT. See the PPT? That's parts per trillion of CFCs in the atmosphere. By 85, the mid-80s, when we start to have problems with the CFC in the ozone, notice it's getting well over 200 parts per trillion. So this is beginning to increase. I want you to keep in mind this graph. Notice how it keeps going up even into the 90s, and it starts to level off. I'll talk more about that when we move on. So the question that ended up becoming asked is there a connection between the thinning ozone and the increase in the CFCs? Well, that's our introduction with chemistry as we're taking a look. And this is a question we're going to take a look at in the next section. Okay, so before we move on, or before I close this out, let's do two simple questions from this area. Stuff in the universe, what is it made of? It's made of matter. So if that was your answer, you are correct. Second, which protects living organisms from ultraviolet light? And why are we studying it for it? It's ozone. That's one of our two substances. Okay? And that's the first section, chapter 1.